Okay, we will continue from the first part that we have covered yesterday. So today we will be covering the second part of chapter 6 on data communication. Okay, so as you can see, we have 5 parts under this chapter. So two of it already covered in part 1, data communication and also networks. So today we will cover another important part, the protocols and also standard involved in data communication, open system interconnection OSI, uh, and the last one is TCP/IP. Okay, and maybe we are familiar with this term TCP/IP, so which represent transmission control protocol and internetworking protocol. Okay, because when we are dealing with data transmission and also communication, so we need to have a standard of rules and also protocol. So which data to enter first, which process to go on first before the message can be delivered to the other person. Okay, so we will see today. So there are various level of processing that involved when we want to communicate our data. Okay, so protocols and standard. Okay, so this slide might be a bit different from whatever I sent earlier in the group chat because I added some explanations to make you all understand. So I will share this lecture note also in the group later on. For now, just try to focus and understand what I try to explain because there are a lot of terms, a lot of protocols involved, and you need to understand all the protocols that is involved in network. Okay, so number 3, protocols and standards. So what is protocol? What is standard? So it's actually two different things. Maybe all the while we understood that maybe protocol is same like standard, but protocol is actually uh, assisting the standard. So standard is agreed upon rules. So we already made a meeting. So we already agreed certain rules, and we come up with a draft of rules. Okay, we call it as a standard. The standard we cannot change. So if you want to change, you need to have another meeting to agree upon another set of rules, updated rules. So this is something that is already documented, and protocol is execution of these rules. Okay, the standard. Okay, so it's a synonymous with rule. Okay, so we want to implement a set of rules, so we need to follow certain steps. So the steps is what we refer as protocol. Even in an event, so let's say you want to make an event, so a dinner or lunch, so you want to make it. So usually we will use this term protocol. So what is protocol is actually the execution of the event from starting until the end. So certain rules that you need to abide. So sometimes if it's involved VVIP in the event, so you cannot like simply allow the the person or others to go on the stage. So even go on the stage, so you need to follow certain orders. So protocol is actually the orders involved in executing something. Okay, so that's number 3. So I will talk more on this OSI and also the other things that we will compare later. Okay, so OSI. So OSI is Open System Interconnection. It's a universally known term in networking, data communication. So Open System Interconnection. So or we call it as a OSI model. It's not the OSI that we all have in a Unimap. So online student information is not that. So this is Open System Interconnection. So if you see, it was established by International Standard Organization or ISO. So maybe we are familiar with this term ISO. Okay, so always ISO means is something that accredit or giving permission for you to do certain things, experiments or certain procedures in a standard way. So the ISO normally they will come up with a standard or documents that allow you to do something accordingly. So let's say you want to do an experiment. I am doing some experiment on air quality measurement. Okay, so let's say air quality measurement you want to measure in Malaysia. So different part. So when you download their ISO document for air quality measurement, so they will say in the document, so you need to have this apparatus, you need to have this equipment. So first you need to do this, second you need to do this. So once you get the data, you need to do analysis like this. So you need to follow. When you follow it in order, then the world will accept it. So that is what ISO will do. Actually, different country will have a different standard. Like Malaysia have a Malaysian standard. So it will be a bit different from ISO. Uh, so we need to follow certain standard in as an engineer. We need to follow certain standards to do certain things. So similarly, in data communication, when you want to do data communication from one place to another place, so you need to follow the standard. You need to follow the correct procedure of doing things. Okay, so that's when this ISO comes inside. So ISO is actually established in 1947. So it's a multinational body, so dedicated to worldwide agreement on international standard. So ISO is actually a biggest organization because it's involved world. Okay, so world is actually coming together to agree with certain procedures. So they want to come up with certain things. So meaning, like the example I told you earlier. So if you, let's say you want to do a air quality measurement in Malaysia, but when you are using ISO standard for air quality measurement, it is accepted worldwide. If you use Malaysian standard, it will only accepted in the Malaysian region. So it's like that. So ISO is actually a very big organization because it's covering a worldwide agreement on international standard. Okay, so an ISO standard that covers all aspects of network communication is the Open System Interconnection OSI model. So it was first introduced in late 1970s. So ISO they came with a standard, a document uh, for network communication, so data communication. So because we have a network, so network is actually a very big thing, a very big thing because it's covering the whole world. So the whole world is connected through networks, through internet. So now we have IoT, we have AI, a lot of things. So we need to have a proper standard and to manage it. And ISO come up with a standard called Open System Interconnection (OSI) model. Okay, so we need to take note. So the term might be similar. ISO is actually an organization, and OSI is actually a model. So model means it's an example or a standard procedure that you need to follow. So don't get confused here between this. Okay, so this is OSI model. Okay, so OSI model in data communication or network communication, it involves all these 7 layers. Okay, so physical layers is number one. So data link layer, so network layer, transport layer, session layer, presentation layer, and application layer. So all these levels, it has a different function that it need to do. Okay, for example, physical layer. So it transmit raw bit stream over a physical medium. So we know, so data in the internet or in the computer, it is all zeros and one binary. Okay, so we can calculate it based on bit. So that's why the term bit rate uh, or bit baud rate. So all these are related to bits. Okay, number single a number of 0 or 1. Okay, so physical layer, so it transmit this raw bit string. Uh, then data link layer, so you define the format of the data. So nowadays we have a lot of documents, so we have different format. So DOCX, PPT, yeah, or PNG, JPEG, JPEG. So all these are formats. So if you want to send a certain document, you need to send it in a proper format. If not following the format, you cannot open. It will come out with the error code. Say this is not cannot be access denied or something. Okay, so you need to send a data with a proper format, and in network layer, so we need to decide which part we want to use. uh, because we are using cable, we are using a lot of things wireless also. We even have a satellite communication. So we need to define which part we want to take. Okay, so similar like how we want to go to a place. So from your campus want to go to a power town, you can have a various route. So similarly, you need to decide. So this network layer will help you to decide. So it will carries the information of which part to use. Okay, so the different layer, it will have a different information for you to transmit. Okay, so number 4, so transmit data using transmission protocol, including TCP and UDP. So these are some of the protocols that we will follow. So you want to transport meaning you carry data from one point to another point. So it will be conducted by a transport layer. Then we have a session layer, so maintains connection and is responsible for controlling ports and session. So different session. So we even have different ports in even in our laptop we can see. So we have a HDMI port, we have a LAN port, we have a Type C, so we have USB. So different session layers. So you need to manage it. You manage it properly in order. So if not, miscommunication will happen. So when miscommunication happen in a bigger scale, so it will be very costly. So for you to do repair, it will cause a lot of damage, and of course it will cause a lot of compensation and also cost. Okay, and presentation layer number 6 ensures that data is in a usable format and is where data encryptions occurs. So data when you are sending, you need to encrypt and also decrypt. So encryption meaning you are locking it in a proper way, and decrypting mean is you are opening it. So it will happen in the presentation layer. So let's say you want to sign a parcel. Okay, from Kanga you want to send to KL. So you cannot just simply go and give. So let's say now is Aromani season, right? Mango season. So you go to the courier. So you just give them the 2 mangoes, ask them to send. So you won't. It's not a presentable. You need to make sure you put it in a packaging. You wrap it, or you put it in a box. Then you pass to them. So that the putting in the box is what we call as a data encryption. And when it reach the person that you are sending to, he will open the box, or he or she will open the box. So that we call it as a decryption, a description. Okay, so the decryption meaning you're opening it. Okay, so it will happen in layer 6 and layer 7. So human computer interaction layer, where application can access the network service. So this is where we are having our maybe our PC for us to communicate. So human computer interaction, or we call it as a HCI. So human are communicating, so like with computer or phone or anything, maybe a data center, or any devices that we are communicating to. Okay, it can be a touch panel, anything. So it will be in the application layer. So all these are involved in OSI model. So you cannot like skip one, or you cannot like say, oh, I only want layer 1, layer 3, layer 5, layer 7. I don't want too many layer, cannot. So you, because it's following the ISO, it's already agreed that when you are transferring a data communication, you need to have all the 7 layers. If one of the layer is not there, so meaning the data cannot be communicated. So the protocol will not allow you to use it. Okay. So it's like you are driving without a license. So when there's a roadblock, so police will check whether you have a road tax or not, you have a proper license or not, are you eligible to drive, are you minor. So if you don't have a proper documentation, a valid documentation, you cannot perform something. So similarly, yeah. So all this will be used to control the communication, so that it will not be abused by anyone. Okay, so you can see, so the interaction between the layers in the OSI. So let's say you want to send something from A. So physically, we will see like this. So you have a PC, PCA, PCB. So in between, you have intermediate nodes. So maybe it's a router, or it can be an antenna. So we only see this, but actually, what is happening inside is this: all the seven layers. So device A will have a 7 layer. So device B will have a 7 layers, and all these intermediate nodes will have its own layers. Okay, so what it will do, the information will pass to application, because in application layer, so there is human computer interface. So you pass anything. Let's say you want to send a email. So you pass to the application layer. So presentation layer will pack it. So session, we will see later how it is done. So session will do its part. So meaning, to the email, so all these layers will add more information. So this part, since you are sending, it will keep on each layer. It will, before it pass to each layer, so its information will be added until it reach the physical layer. From physical layer, it will be transferred to maybe intermediate node 1, then intermediate node 2, then it will pass to device B's OSI layer. Then slowly, one by one. So once it reaches physical layer, so physical layer will take its information. Then the remaining information will pass to data link. So when it reach data link, so data link layer will take its information. The remaining it will pass to the other. So similarly, it will do for until layer 7, and in device B at the end, only the email will be there. So that is how the communication is happening. Okay, throughout the world. Okay, throughout the world using the OSI model. Okay, so it's very, for us very hard to imagine, but that is how engineers have formatted it, so that communication can happen. Okay, so I already explained this, so I'm not really going. You can have a read about this. Okay, so I earlier I explained this. So let's say that from layer 1, so layer 2 will remove the data meant for it and pass the rest to layer 3. So layer 3 then remove the data meant for it and pass the rest to layer 4, and so on. It's in this process. So each layer will only take whatever belongs to it. The remaining it will pass. So let's say here you have 100 bit. So maybe it take is a portion. So maybe 95 bit pass to this. Then maybe 90 bits pass to layer 3. At the end it will be 0. So only the message will be uh, delivered. Okay, so I'm not really going through. You can have it by own. Okay, so interfaces between layers. So you can see. So in between the white color. So 7, 6 interface meet. So interface between layer 7 and layer 6. Okay, so that is, so each layer will have its interface. Okay, so interfaces between layers, the passing of the data and network information down from the layers of the sending device and up through the layers of the receiving layer. So that's why we can see here the information is going downward, here it's going upward. Uh, so it will establish a connection. Okay, so each interface define the information and services a layer must provide for the layer above. So interface is just like a connectors between the layers. Okay, so the organization of the layer. So the 7 layer can be divided into 3 subgroups. So earlier we have seen in OSI model, so we have 7 layers. So the 7 layers we can divide it into 3 main groups. Okay, we can group it together. So 3 subgroup. So the first subgroup we call it as a network support layers. It is layer 1, 2, and 3 because it's dealing with physical aspect of moving data. So this in this network support layers, the data is transmitted from one place to another place. Maybe is using a cable or wireless. In this layer, network support layers, the communication happens. Okay, then you can see um, layer 5 session presentation. So you can group it together. Okay, we call it as a upper layer. So upper layer is implemented in the software. So usually we will use a software. So like now we are using a Google Meet software or app. Okay, we are using phone. You are using an app. So it is actually the upper layer. So the layer that communicate with the human being or the person. Okay, so upper layer. Then we have a lower layers, the combination of hardware and software, except of the physical. So lower layer is actually in between network support layer and also upper layers. Which is in between sandwich. So this is actually upper layer is dealing with human being. So it's presenting the message. So it will pass to lower layers. So it's the hardware and software. So it will do the conversion, everything, and it will pass to the network support layer for transmission. Okay, so there are 3 subgroups involved. You can put the 7 layers into 3 subgroups. Okay, so you can see. So you are passing a message. So first you see how long is the data. So data is actually very small. So we reach the layer 7. It adds its information and pass to here. So it becomes like this long. Then here H6 is added to D6. Uh, so you pass to the next layer. Uh, so you can see it keep on adding. So after some time in layer 7, it will be a long message and it's converted to zeros and one. So it will pass to the transmission medium, so wired or wireless. Then it will reach here. The message will become shorter and shorter because each layer will take its information and pass the rest. Okay, so aiders and or trailers will be added to the data unit. So you can see here. Uh, so this is the data. So D7. So you can see H7 is added. Here H6 is added. H5 is added. H4 is added. H3, H2. Here supposed to go. Maybe H1 is converted to zeros and one. So this is what we call as a aider or trailer. So why you want to add a aider or trailer? Because you know where you need to cut and take information. Because each layer will afterward it will take its information, right? So you will put your data, you put like a buffer in between. So that is what we call as a aider or trailer. Then you put the next data, then you put another aider or trailer. So each layer will know its own aider. It's like a label, lah. So it's like a label. So it will only take what belongs to that label and pass the rest. Okay. So I already explained all this. And layer 1, so transform. So usually what will happen in physical layer 7, so once it reach this binary code in the last layer, so what it will do, it will be converted to electromagnetic signal. So before transfer, so it will change to electromagnetic signal, and it will be transferred along the transfer links. So once it reach here, it will be converted back to to is a digital form. So this is digital form converted to electromagnetic form, transferred, reach here, it will be digitalized by. Okay, then it will be extracted. Okay, so that's what he is saying here. Okay, so physical layers. Okay, physical layer. So we can see how it is converted. So data from the previous layer, so it will be transferred. Uh, so here, so the coordinates the function. Physical layer actually coordinates the function required to carry a bit stream over the physical medium. So what physical layers? So we will see all the layers shortly. So for first start with physical layer. So it coordinates the function required to carry a bit. Because when you this is the transportation medium, the transmission medium. Okay, so when you want to send it, so you need to properly send it so that all the information will be received correctly. So it deals with the mechanical and electrical specification of the interface and transmission medium. So it defines the procedure and function, the physical devices and interfaces have to perform for the transmission. So it will prepare the transmission to happen. So the physical layer. So I only want to like tell this. So the physical layer is responsible for the movement of individual bits from one node to the next. So earlier we have seen, okay, so in this example, so from here it's sent to this, then it's sent to this, then it's sent to the destination. So in between you can have a lot of nodes. So sometimes you will have only one, sometimes you don't have. So sometimes you will have like 10 in betweens. So all the nodes, it must have this OSI model for it to function. Okay, so physical layer is responsible for the movement of individual brief from one node to the next. Okay, then we have a detailing layer, so layer 6. Okay, so what detailing is doing? So you can see is adding the so this is the data. So this is the header or trailers. Okay, so to put in between. Okay, so what a detailing layer is doing? So the detailing layer is responsible for moving frames from one node to the next. So earlier it was individual bits. So now you already form it as a frame. So meaning it's a bigger data. So it's no more in the bits. It's a combination of bits. That combination of bits is what we call as a data. Okay, so data. Okay, then network layer, what is it do? So layer number five. So the network layer is responsible for the delivery of individual packets from the source host to the destination host. So what it will do? So once the network layer, so network layer will be in the sender and also receiver. So what network layer will do? So it will deliver the individual packet. So whatever is a wrap, whatever message that is read, so this network layer is responsible to deliver it deliver it to the correct destination. Okay, so it will send from the source host to the destination host. uh, okay, then the transport layer, so what it will do, the transport layer is responsible for the delivery of a message from one process to another. So earlier it was a packet. It's a packet, so it will collect first. So collect first, and it will deliver. Okay, so once it already have accumulation, so it will deliver it as a message. Okay, from one process to another. So of course, it is still packed. Okay, so the data that is still packed, it will combine together, and it will pass to the next. Okay, so the next it will pass to the session layer. So the session layer is responsible for dialog control on and synchronization. So you can see it does various data combined together, but it's still wrap data. So imagine you are sending a parcel, postman. Okay, what postman will do? Postman will go and collect. So he will have various various envelopes of letters. So what he will do? He will sort it out so maybe what postman will do, so they will sort it out in terms of maybe a zone. Okay, so maybe they want to send to the Kanga first, then they want to send to Arau, they want to send to Pau. So they will divide into zone. So they want to synchronize the next action. So they want to make it things easier. So this session layer will formulate this. Okay, so you can see the session layer will have organization. Okay, it will organize the data into a uh, presentable way to the next layer. So the next layer is the presentation layer. So presentation layer earlier we saw it wrap. Okay, it wrap all the information. So it encrypt. So here in the presentation layer, so encryption and also decryption will happen. So if you are in the standing node, it will encrypt. So it will have a translation, it will compression, it will have a encryption done in the source host, and in the destination, it will start to open up. So translation to understand. So earlier, if it was compressed, it will decompress it, it will de-encrypt it. Okay, so it depends on which layer. Okay, so presentation. So because after this presentation layer is already application layer. So application layer you already presenting it to the actual person. So the actual person cannot understand the data in zeros or ones, or in very incomplete. So you need to complete it so that application layer can show to the human being. Okay, so this is the last one, the seventh layer. So user program. So we can see. So the data initially we have in a various format. So let's say docx, or we can have a JPEG format. We can have a PNG. We can have a PPT. So all these what we can understand, what we can see. So this will be converted. Okay, so this in the sending node and this in the receiving node. Okay, so once this format will be converted into a data format before it pass to the next layer, and here upon receiving it will be converted back to this. So that's why when we are sending email, so we are sending in a written text, we call it as a ASCII code, ASCII. So when you are pressing A in your keyboard, so it will be converted into its own ASCII code. Okay, so computer understand the ASCII code. So when you press A, we understand as A, but computer understand based on the ASCII code. So in between, the ASCII your A input will be converted to ASCII code. Your computer understands. So that is what is happening here. Okay, so we understand this in this format, but the computer don't understand it. It will convert it into the form that the network will understand. Okay, similarly here, so if the process only stop at this, we only will understand the information in the ASCII code. The ASCII code must be changed to the actual form that we understand. Okay, so that is what happening in the application layer. Application layer is responsible for providing services to the user. User is us. Okay, you and me. So if not, we cannot use the laptop if we don't understand. We are only understand alphabets, so we only understand numbers. So we cannot understand the coding that happening behind. Even the coding that we write, we need to write it in a ASCII code or a normal text. Now then only we understand. But computer need to convert it. That's why we have a compilers. Compilers. So if you are familiar with embedded system, so you know Whatever the code that you are writing, the compiler will convert it for the microcontroller to understand. Okay, so similar thing is happening here. Okay, so this is summary of the layers. So each layer will have a different function, but you need to run it together in the OSI. Okay, so start from the physical, so data link, network, transport, session, presentation, and also application. So all this layer have its own functions. To Okay, so that's on the number 4 OSI. So now we will see a little bit on the TCP IP. So TCP IP stands for Transmission Control Protocol and Internetworking Protocol. So both must come together. So if one, it's like not complete. So it must be combined together. But it's a two different protocol combined together to help us do something. Okay. So transmission control protocol or internetworking protocol TCP/IP. So earlier we saw OSI model is having 7 layers, but TCP/IP is actually only having how many? 1, 2, 3, and 4. Only 4 layers. Okay, so the layers in the TCP/IP do not exactly match those in the OSI model. The original TCP/IP was defined as having 4 layers: host to network, says here, then internet, okay, transport, and also application. But when TCP/IP is compared to OSI, we can say that TCP/IP protocol is made of 5 layers. So it's actually not 4 layers. So it's actually, if in relation to this, is having 5 layers. So it has a physical layer. So data link, so network. These three you can escape. You must have because it's dealing with the device. Okay, then we have a transport layer. Then straightaway application. So presentation and session is not around, but it's combined. So combined with the top layer. Okay, so physical and data link layer. So what's the difference between OSI? So TCP/IP does not define any specific protocol. So it's more dynamic, it's more flexible. So it supports all the standard and proprietary protocols. So it support most of the protocols. So even is ISO or it can be other countries' protocol. So it fulfills. Okay, a network of TCP/IP can be a LAN or one. Okay, so it's a combination. Network means it's a combination of few TCP/IP. So we call it as a LAN or one. Okay, so this blue color is added to the slide that I gave earlier. So I will reshare back this slide after the class because I tried to explain it, and I need to explain it within 1 hour, right? So I try to make it in an analogy for you to understand. So that's why I added. Even the next slides also will have. So network layers. So TCP/IP support internetworking protocol. So protocol between networks. So one network, two network, so it can communicate. So that's why we have a lot of, so like Unimap. So Unimap, we have our network inside. Yeah, so the TCP/IP inside the Unimap campus, so it's the same. Okay, it's the same. So if we want to access within our network, so we can even use a local network. Local network. So let's say it's in the same building. So even you can share things in your network. So you can name a network. You can create a network to share files, to share printers. So we have seen this yesterday about that. Uh, and within the university, we can have a lot of access that we can set. So we call it as a networking. So networking inside the campus. Inter networking means, so let's say you have a network in Unimac, and Polytechnic is at its own network. So you want to communicate between Unimac and also Polytechnic. So you can use the inter networking protocol. So we can do that using a TCP IP. Uh, so that's why whatever criminal activities or any activities, so they will check where is the IP location, so where is the person access it last. So that's how they communicate. So internet networking. So this internet networking is the full name of internet. So now we know what is internet. Internet is actually internet networking between various TCP IP. So in the world, we have millions of TCP IPs, small networks. So all these networks are interconnected. So that's why we have a lot of information available in Google because all these networks are interconnected. So when you do some search in the search engine, so immediately all the information will be compared to the other network. So it will find all the network and it will have a search list, result list. So that is what is happening. So IP uses for supporting protocols. So we have a ARP, address resolution protocol. So we have a reverse resolution protocol. So RARP is a reverse address. Address also have some mistake. Okay, so reverse address resolution protocol RARP. Then we have Internet Control Message Protocol ICMP and Internet Group Message Protocol IGMP. So I will explain little based on the analogy for you to understand. Okay, so what is IP? So IP you can ever read. So IP is based on the address that we give. So you can see what is IP about. So imagine you are sending a letter through a postal service. The IP address is like the mailing address on the envelope, ensuring the letter reaches the right house. So if you want to send a letter, so make sure you write the letter, the address, the name of the person, and the address, the postcode, and the town, everything you will write. Then you send it. So the postman know. Okay, oh, this must be sent to house number 185. So you will make sure you will not send to 186 because you already mentioned it. So IP address is like that. So whatever information that you are sending, I told you it will be packaged. It will be so the packaging is like an envelope. So on the envelope, you need to write the address. So the on the envelope, so you are assigning the IP address. So IP address to that particular node or the device. Okay. So if you want to understand IP, so imagine you are sending a letter and you are writing a mailing address. So the mailing address is the IP address, okay, of that particular transmission. Okay, so IP transport data in packets called datagrams. So the term datagrams, so it's actually IP transported data. Okay, then we have ARP, so address resolution protocol. Okay, so what is ARP? So imagine you are at a party and want to talk to someone named John, but you don't know what he looks like. So you ask around who is John. When John hears his name, he raises his hand and says, "That's me." Then you approach the person and talk. ARP is like that address protocol. So at times, the packages can be can some error happen or virus attack or whatever. So it will lose the address. So the person will go to the party, suddenly don't know who to meet, or don't know who is the person is supposed to meet. maybe some information like loss. Then this address resolution means you want to give solution. So address resolution protocol or ARP, what it will do, so let's say your parcel already received uh, without address, it will try to identify where it's supposed to deliver. So similar like this condition. So if you know John and you know how John look like, you straight away can go. So that is like this IP. But in the instance that you don't know how John look like or how where to deliver the message, then this ARP will try to raise a flag. So flag means it's like a query to the network. So the network will try to find where it's supposed to send, and once John hear the name, he raise the N. So similar. So the ARP will raise a flag. The network TCP IP, the packages inside the TCP IP will respond. Okay, so it suppose belongs to me. Then the package will be delivered to that particular person. So typical networks such as LAN, each device in a LAN identified by physical address. So usually imprinted by network. So our laptop, we have a network interface card, or we call as a network card. So network card or NIC. So all this NIC, it has its own address. So when you're sending a parcel, so let's say the parcel gone missing, so it will raise a address resolution protocol in order to send. Okay, so it belongs to person A's NIC. So it will send, so immediately send the information to your NIC. Okay. Okay, then okay, so ARP I already addressed. Okay, RARP. Okay, RARP. So what is RARP? Can you find the name? Okay, just give you some exercise. RARP. What is RARP? Anyone? Try to find RARP. ARP we know, Address Resolution Protocol. What is R? No answer? Very hard to find. No one want to answer. So it's here. Reverse Resolution Protocol. Okay, the Reverse Address Resolution Protocol, RARP. So there's some word address is missing. Okay, so what RARP does? So I give another analogy. So imagine you are at a large convention center with many different meeting rooms, and you are just arrived with a special badge that has a unique identifier number on it, but no other information. So you need to find out which meeting room you belong to. Okay, so earlier ARP we know, you go to the function, you just call who is John, John raise hand, then you straight away go. So similar in network, you have the parcel, so you're asking where this parcel must be delivered. So the person raise the hand, so you send to the person. Okay, so that is ARP. So reverse ARP, what it does, so you reach to the event place, so you already have all the information, but you don't know where to go. So you need to find out based on the information you have. You already have the special number, so you need to find which network card you need to go. So you need to find within the network. So you will have the process to have the RARP. Okay, so that is a RARP. Then you have ICMP. So all these are a lot of protocols involved. Okay, so ICMP is imagine analogy. Imagine you are sending a series of letter through postal service to a friend, and you want to ensure each letter reaches its destination and know if there are any issue along the way. So ICMP is, as you can see here, Internet Control Message Protocol. So even our emails, so emails we are sending. So at times we are sending our email. We don't know whether the other person received the email or not, whether the person already opened the email or not. So there is a mechanism in the email. So in the email setting, that you can turn on this ICMP. So meaning you send an email. Once the person receive the email and the person open, it will send a receipt to you, saying that okay, the person, this person already opened the email. So then you know the message is already delivered and the email is already open. So that is the function of ICMP. So you are sending a lot of letters through a postal service to a friend, and you want to ensure, you want to make sure the friend receive it and you open without any issue. So that's the function of ICMP. So at times in our network, we need to have this kind of information to make sure the information is delivered correctly. So if this kind of case is involved, then you need to use this protocol. So you don't need to use all the protocol at one time. So whichever is related, whichever based on the situation you want it to. Uh, so you need to use the proper protocol. Then we have IGMP. So IGMP is Internet Group Message Protocol. Okay, so imagine you are in a large apartment complex where there are several different interest clubs like a book club, movie club, and cooking club. Each club meets regularly in a different room of the complex, and you want to join or leave these clubs based on your interest. So let's say you just bought a new apartment, a luxury apartment. So usually luxury apartment will have all the clubs. So you can use the gym facilities, you can use the swimming pool. So imagine all these are different facility, and you already became a resident. You already became a member of the network. Okay, the apartment network. So now you want to exercise your right because you are paying for it, right? Normally we'll have a membership fee. So you are paying for it. So what you need to do? Usually, if you want to register to this club, you need to contact the leader. So the leader is will assign. So let's say you contact the leader. So you cannot directly go to the club because the club you need to have a valid entry pass, or you need to register to it. So what you do? So you just take your phone, you contact the manager of the apartment. Say, I am belongs to this apartment number. So I just came to this apartment. So I want to register to movie club. So can you help me to register? So what the manager will do? He will say, okay. So you will verify your detail. Okay. So this person is belongs to my apartment. Okay. So I will register you to the movie club. So once the person register you, then you can have the access to the movie. So once next time you want to go to the movie club, movie club's activity, so you go there, the person check or your name already there. So that is the function of IGMP. So at times you will have this kind of situation where you need to contact the router. Okay, you want to send the information you want to access, so you need to go through the router. So the router is the one who assign you to the proper channel. So that's the function of the router. Usually we have right the router in the house, in the internet, in the campus. So the access point. So that's the function. Access point will give you the access for certain permissions. So you cannot bypass um, the the router. Okay, so that is the function. Okay, so actually there are a few more slides to go. Maybe I try to finish it. Okay, so then transport layer. So transport layer, we have two protocols. We call it as a TCP. So TCP is actually the uh, you can see transmission control protocol. Okay, so transmission control protocol. Okay, so TCP must come together with IP for you to have. So what TCP does? So imagine you are sending a series of important letters to a friend, and you want to make sure each letter gets there safely in the right order, and that your friend receives them all. So it's similar like the ICMP, but this is in a bigger scale, bigger layer, because this is more on the bigger layer. So under that we will have ICMP. Okay, so you want to send you want to make sure they receive it safely, the right order, and your friend receive them all. So it's similar like uh, how to say, the registered post. Okay, register post you need to pay, so you will write all the detail. So the postman will go to your house. Normally what postman will do, he will just put the letter in the post box, right? So what this TCP will do using the ICMP protocol, so what it will do, it will go to the destination. So normally register post, what postman will do, you will wait, you will ring your bell, you will wait until the person come, you will say, so what's your IC number, you will write it down, then only you will hand over the parcel. You want to make sure you hand over to the right person. Okay, so TCP will ensure that. So this is very important because we don't want our emails to reach wrong person. We don't want our information to go to wrong parties. So TCP will control it. Then we have UDP. Okay, UDP. So imagine you are sending out invitation to a large party, and you don't need to confirm that everyone received the invitation. You just want to get it out, word out quickly. This is like a normal post. You just send it out, so whether the person receive or not, you don't really care. So even postman also don't care. So you see the address, you just put in the post box, and you will leave. So that is UDP. So at times you will use TCP, at times you will use UDP. And nowadays we have this. Okay, so the new transport layer protocol, we call it as the stream control transmission protocol, or SCTP. So imagine you're coordinating a large event that involves multiple activities happening simultaneously. You need to communicate with various teams to ensure everything runs smoothly with messages that are both reliable and ordered within each team's communication, but can be sent independently to different teams. So this example is like your WhatsApp group. WhatsApp group, you can have 1,001 group in your WhatsApp. So whatever you send, you want to send. So let's say you are the admin for all the 1,000 groups. So you want to send different information to different group without confusing other groups. So if you want to send one particular information to group A, you just put in that WhatsApp group for group A. So all the person in the group WhatsApp group A, they will understand it. Okay, so this is the new one, because of this SCTP. So that's the reason why we can have a lot of flexibility in WhatsApp. So it's only started to boom for past like 5, 6, 7 years. Before that, we don't have this. This SCTP, it gives that flexibility. Okay, so the application layers. Okay, so equivalent to combined session. So we always use this at the topmost when we are dealing with the person. Okay, so application layers is on top. So this is practically how TCP/IP will operate. So using 4 to 5 layers compared to OSI layer, each has 7 layers. Okay, but both also are important. Okay, so that is about TCP/IP and OSI. So here I have included 5 examples. So you can try some of the tutorial questions. Example 1, example 2, example 3, example 4, and example 5. Some can even have some calculations that involve. Yes, you can try it yourself. Okay, so any question? Okay, sorry I took extra 2 minutes. Okay, because a lot of information to share. So any question? No question? Okay, so hopefully you all understood. It's a lot of information, I believe. But I will give you the video and also a puzzle assignment. So try to go through again. Okay, for you to understand better. Okay, so I will pass you the attendance link. If you don't have any questions, so please look at the chat box. Okay, so please don't forget our midterm exam. So it will be on Thursday. So 8:30 to 9:30. It will be in Dewan Kulia. Dewan Kulia, as I already booked earlier. If I'm mistaken, Dewan Kulia 3 and 6. So I will put in the information in the chat box. Yeah, any questions? I heard some noise. So if you have any question, you can ask. Okay, so I will open the link. Is the link open? Yeah, okay. You can see some numbers. Okay, so today will be the last class with me. Okay, so I have covered until chapter 6. So after this, Dr. Akmaria will cover for you. She will take over from next week. Okay, so we will see for exam clinic. I'm not sure about Dr. Akmaria whether she want to do any clinics or not, but I will do at the end of the semester. So we will see more on the scope that we need to focus for your final exam. Okay, so 404. So if you don't have any questions, so we can leave. You may leave. You can put the attendance and leave. Thank you.
Thank you, sir.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Yes, sir.
Thank you, Doctor.